Hi there, today we're going to take a look at understanding decimal place value. Our I can statement for today is I can recognize that in a multi-digit number, a digit in one place represents 10 times what it represents in the place to its right, and 1/10 of what it represents in the place to its left. We use a number system called base 10. This means that place value in any number is based on a pattern of tens. Look at the following place value models for whole numbers. If we take a look at the models below, we see that 1,000 is 10 times 100. So that just means that if we take this 100 flat, it's going to take 10 of them put together to equal this 1,000 cube. So 10 times 100 is where we're getting 1,000. 100 is 10 times 110. So if we start with this 10, which is one rod, and we put 10 rods side by side, that's how we end up with our 100 flat. So 10 times 110 equals 100. 110 is 10 times 1, 1. So we have this one little cube, and if we stack 10 of them together, that's how we're coming up with our 10 rod. And then we have 1, 1, which is one little cube. So as we move to the left, we're getting 10 times greater. So it takes 10 ones to make a 10, 10 tens to make a 100, and 10 100s to make 1,000. Place value in decimals is just like place value in whole numbers. Look at the following place value models for decimal numbers. We're going to write the missing numbers in the equations below these place value models for decimals to show how hundredths, tenths, and ones are related. So we're starting with our ones. We have a hundredth grid, and the entire grid is shaded in. So that is showing one whole. Well, if we take a look, it says 1 equals blank times 1/10. How many of these tenths do we need to make one whole? So here is 1/10. So in order to have one whole, we need 10 of them. So 10 times 1/10 is going to equal one whole, because here's 1/10. Each column is a tenth, and it takes 10 of them to make that one whole. Next, we have our tenths. So here is 1/10, and 1/10 equals blank times 100. So here's our hundredths. Here's 100th. How many of these hundredths does it take to make 1/10? Well, it's going to take 10 of them. We got to fill up this entire column, and there's 10 in one column. So that shows us that 10 times 100th equals 1/10. And then here is our hundredth. So look at the pattern in the chart. So let's start with 1,000. If we take 1,000 and we multiply by 10, that's going to equal 100th. 100th times 10 is 1/10. 1/10 times 10 is 1. 1 times 10 is 10. 10 times 10 is 100. 100 times 10 is 1,000. And 1,000 times 10 is 10,000. So every time we multiply by 10, what is happening to that 1 in our chart? It started in the thousandths place, then here it's in the hundredths place, the tenths place, the ones, the tens, the hundreds, the thousands, the 10,000s. So every time we multiplied by 10, that 1 shifted one place to the left. So it increased in value by 10. Well, if we go the other way, if we start with 10,000 and we multiply by 1/10, 10,000 times 1/10 would equal 1,000. 1,000 times 1/10 is 100. 100 times 1/10 is 10. 10 times 1/10 is 1. 1 times 1/10 is 1/10. 1/10 times 1/10 is 100th. And 100th times 1/10 is 1,000. So as we moved up the chart, we noticed that the 1 is now moving to the right one place value every time. So it is decreasing each time. The value is now 1/10 of what it used to be in the place before it. So if we look over here, multiplying by 1/10 is the same as dividing by 10. So if we take the number 10 and we multiply it by 1/10, we're going to end up with 10/10, which is 1 whole. Or we could say 10 divided by 10, which is 1 whole. So when we're multiplying by 1/10 every time here on this left-hand side, that's the same thing as dividing by 10. So 10,000 divided by 10, 1,000 divided by 10, and so on and so forth. So every time we multiply by 10, that digit is going to move one place to the left. If we divide by 10, that digit is going to move one place to the right. So when the digit 1 moves one place to the left, its value is 10 times what it was. So if it is increasing one place value each time, it's 10 times its original value. When the digit 1 moves one place to the right, its value is now 1/10 what it was. So it's decreasing. It's now 1/10 the value that it started with. So let's take a look at just some basic place value. We have to figure out, since what's my value, and this is number 4 over here talking, so we're going to look at the 4 and figure out what is the value of that 4 in each number. So we have a 4 right here, and the 4 is in what place? Well, here's a comma, so that'll help us figure out what place this 4 is in. So the 2 is in the thousands, the 4 is in the 10,000s, so that means it would have a value of 40,000. Okay, now we have a 4 right here, and the 4 is in what place? Yes, it's in the hundreds place, so that means it would have a value of 400. All right, now the 4 here. Again, we have a comma. It's in front of this comma, so we know this is our thousands, 10,000s, and 100,000s. So if the 4 is in the hundreds thousands, then it has a value of 400,000. And then our next number, 1,324,968. The 4 is right there in front of the comma, so it's in the thousands place, so that means it has a value of 4,000. And last, we have a 4 here in front of that second comma, and we would read this number as 4,182,392. So the 4 is in the millions place, so that means it would have a value of 4 million. So now we're going to take a look at the value of the same digit in two different numbers. So first we're going to compare the 4, or compare the value of the 4 in 128,461 and 1,324,968. So if I look at the 4 in the first number, this value is 400 because it's in the hundreds place. And the value of the second 4, the 4 is in the thousands place, so that's going to have a value of 4,000. So they're asking us to compare these two values. So if we look at 400 compared to 4,000, is it greater than or is it less than? All right, 400 is less than, and if we look, the 4s are just one place value apart. So that means that 400 is 1/10 the value of the 4 in 4,000. So we can say the value of the 4 in 128,461 is 1/10 the value of the 4 in 1,324,968. We could also look at it the other way and say that the value of the 4 in 1,324,968 is 10 times the value of the 4 in 128,461. So we're comparing them both ways. If we compare the smaller value to the larger value, we're going to have to say that it is 1/10 the value. And if we're comparing the larger value to the smaller value, we're going to say that it is 10 times the value of the number. Right now, we're going to compare the value of 4 in 42,369 and the 4 in 413,789. So if we first look at this 4, it is in the 10,000s place, so it has a value of 40,000. And then if we look at the second 4, it's in the 100,000s place, so it has a value of 400,000. And if we compare 40,000 to 400,000, again, we see that 4, it's just shifted to the right one place. So it's showing that it is 1/10 the value of that 400,000. So again, we could compare it two different ways. We could first say that the value of the 4 in 42,369 is 1/10 the value of the 4 in 413,789. Or if we compare the larger value, we could say that the value of the 4 in 413,789 is 10 times the value of the 4 in 42,369. So if we're comparing the smaller value to the larger value, that's when we're going to say that it's 1/10 the value. And if we're comparing the larger value to the smaller value, is when it is 10 times the value of that number. All right, guys, so if you can just remember that, it's set on a base 10 system. Every time we increase and move to the left, we are talking about it being 10 times greater. And if we are moving to the right, we are decreasing, or we are becoming 1/10 the amount that we started with. Good job, guys.